Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rozan, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Shreya Lowmaster from Thermo Fisher Scientific.
Hello, everybody. My name is Shreya Lowmaster. Thank you for the introduction. Today I will be speaking about our new product, ExpiCHO Stable Production Medium. I would first like to go over the overall agenda for today. I will be covering the transient to stable solutions for CHO cells, and I'll be focusing on one pain point of how you can go from the research scale into a commercial production scale, followed by comparing the transient expression versus the stable production workflow. I will also be highlighting a case study we performed of a high-producing ExpiCHO stable clone and how we created it, concluded by a summary. So right now, researchers are demanding higher titers in transient systems. Many people are using CHO systems as an alternative over the HEC-293 systems. Currently on the market, there is the ExpiCHO expression system kit that was developed for transient expression pools used for research use. Now I introduce the ExpiCHO stable production medium, which again is a commercial scale production medium. These two products are integrated into one system, creating one stable solution. So I would like to focus on a pain point. So generally speaking, for a stable clone development, which is a clone process to scale up into a larger bioproduction process, you would begin with a target selection with pools, followed by stable clone development, and then you would have to go into a medium screening and optimization stage. So normally, you would have a medium that is optimized for your cloning process, and then you would transition into a production medium in your manufacturing process. Most of the time, these two products are not integrated within each other, and for this reason, it can take an average of 6 months to adapt the cells. So at this point, I would like to ask the audience a question. How long does medium and feed screening and optimization take you during process development? 0 to 1 month, 1 to 3 months, or greater than 3 months? Can you please click on the screen? So it seems as though most are experiencing greater than 3 months at this point, which for this reason we are focusing on this. With ExpiCHO stable production medium, you can completely bypass this step and eliminate the medium screening and optimization phase out of your process. This creates a time-saving aspect by using the integrated ExpiCHO system. So now I would like to compare the two workflows, the transient workflow versus a stable production workflow. So in a transient system, you would begin with your transfection, use ExpiCHO expression medium throughout the entirety of the process using a vector of choice and with the transfection reagent, and then you would add enhancer and feed, as well as apply a temperature shift depending on the protocol of choice. At the conclusion of this, you would harvest on day 14, and it's important to note that it's one transfection per transient production. If you would like more product, you will have to repeat the step. Whereas in a stable workflow, similarly, you will use expression medium going from transfection through selection, again with your vector of choice in your transfection reagent from the ExpiCHO expression system kit. And once you get through the clone selection, that is the point you can switch into stable production medium to scale up. Through a stable workflow, and once you have created your clone selection, you can put down a master cell bank for multiple productions. And this will be an upfront, a longer process. However, it will save time in the long run. So now I would like to further compare the products that you would use in a transient system versus a stable production system. In the transient expression system, you would use the CHO line, which is the ExpiCHO cells, that is a higher producer and selected for higher transfection efficiency, paired with the ExpiCHO expression medium, which is a transfection medium that is optimized to work with the ExpiCHO cells, as well as the ExpiCHO transfection kit for excellent transfection efficiency and high titers. As I just mentioned, the ExpiCHO transfection kit is a higher efficiency lipid-based transfection kit. All three of these are available in the expression system kit currently on the market for transient expression. Similarly, for stable production, you would also use the same ExpiCHO cells, the same expression medium for transfection and going through your clone selection, and the ExpiCHO transfection kit. It is important to note that you can use the same ExpiCHO cells that are currently available as non-cGMP cells. However, they will be launching in September of this year. So you can transition into a recently launched commercial scale-up medium at any point post-selection, which is integrated into the ExpiCHO family of products. The ExpiCHO stable production medium is available in both liquid and advanced granulation technology, or AGT, powder formats. AGT is better for shipping as well as storage. As I mentioned, the ExpiCHO cells are a very robust cell line, and they are higher producing in transient expression. This is transient expression in comparison to our competitor systems, as well as the XB293 system. As you can see from the ExpiCHO expression system kit, regardless of which protocol you choose to use, the ExpiCHO cells are better or equal to the three protocols or our competitors. So now that I've introduced you to our integrated ExpiCHO family of products, I will walk you through a case study of how we developed this high-producing stable clone. So this is our case study, and it's our process that we went through for a stable cell line development workflow. First, you would thaw your ExpiCHO cell bank, perform a stable transfection, and then you would select your integrated clone expressing your gene of interest, followed by a limited dilution cloning step. This is our proof of concept. However, there are other systems available on the market. And then we continued into clone screenings as well as productivity assessments. We also concluded this with a stability assessment. The reason for this is to check to see if the stable clone that is producing high titer is not losing expression over time. So before I go into this slide, I would like to show on the bottom right of the screen, this is the overall stable cell line development workflow that we follow. The grayed out area is the portion that I am focusing on, so it starts at the top left, continues to the right, goes back down, and goes back to the bottom left. So this is the stable clone selection that we performed. This is a selection process to get diverse pools to increase your chances of a high-producing stable clone. For selection 1, we used a lower antibiotic pressure. Once the cells recovered to greater than 85% viability, this is when we proceeded into selection 2. Selection 2 is a higher antibiotic pressure, and once the cells recovered to greater than 90% viability, we followed it by limited dilution cloning. So as I mentioned, we performed limited dilution cloning. This is our proof of concept and our feasibility studies. Again, there are other options on the market today. This resulted ultimately in a stable clone for us. We went with the ExpiCHO pool, and we seeded at half a cell per well in 96 well plates and performed a static incubation for 12 days. From that point, we had 80 to 90% confluency in 96 well plates that were expanded into 24 well plates. Followed by that, we had 30 to 50% confluency that were expanded into 6 well plates. The last 3 steps of this process are actually our primary screening, which is a glucose-only screening. So as I mentioned, we went through a primary screening, which was a 5-day assessment. And from that, we went into a secondary screening, which was a 14-day glucose-fed only assessment. And in between this, we also conducted a stability assessment, again, to have a cell that is not only high producing, but also stably expressing the protein over time. And then we went into a tertiary testing assessment, and from that, that is a feed-based fed batch process that we recommend efficient feed C+, and we use it in a 2X form. And from this, we received our top clone, which is a stable ExpiCHO clone producing greater than 3 grams per liter of IgG titer. From this clone, we performed multiple experiments to see how adaptation would work. So as you can see, the ExpiCHO expression medium, which is our control, in red, and then ExpiCHO stable production medium, which is in blue, and then two of our competitors, each paired with their respective feeds. This is again the stable ExpiCHO-S clone, and they were passaged every 3 to 4 days and seeded at 200,000 cells per mil in shake flask. You can see that ExpiCHO stable production medium requires no adaptation, simply from thaw. In addition to that, even after 5 passages for the competitor media, it lags in VCD. And from this, we show that direct adaptation results in superior growth for ExpiCHO stable production medium for your ExpiCHO-S stable clone. And from this, we wanted to see how would it look in a small-scale bioreactor. For this reason, we went into the Amber 15. This is again the same stable ExpiCHO-S clone in the Amber 15 using a fed batch process of the recommended efficient feed C+ and a 2x concentration. So you can see that we also have it in AGT, as I had mentioned, as well as the liquid for ExpiCHO stable production medium. You can see that it's very comparable, and you can expect very comparable results in viable cell density. This is important to note because you will start, generally speaking, using the liquid at first, and then once you scale up your process, you can be confident that you will receive comparable results. In the same experiment, we proceeded to look at the titer for the 14-day experiment. So again, AGT and liquid for the ExpiCHO stable production medium, very comparable results as far as titer, but not only that, it's superior titer in comparison to our competitors that were paired with their respective feeds, therefore outperforming the competitor medium. Followed by this, we decided we would like to scale up into a larger bioproduction process. For this reason, we went into the 50-liter single-use bioreactor. The initial run seems to translate well from a small-scale bioreactor with minimal process optimization or feed optimization. This is the same ExpiCHO-S clone in a fed batch process using the ExpiCHO stable production medium liquid with efficient feed C+ 2x. As you can see, it's superior VCD, and then on day 18, also 3.5 grams per liter titer. So at this point, again, I would like to ask a question to the audience. How important is it for you to be able to predict the quality of your stably expressed protein? Is it crucial, nice to have, or not important? Please click the screen to submit a response. Okay, thank you. So it looks like it is extremely crucial, which is great to see. And for this reason, we proceeded to look at product quality. So as you can see, on the left of the screen is the transient pool, or transient clone. You can see that it's extremely comparable to the stable workflow, and it has very similar product quality. In addition to that, with ExpiCHO stable production medium and ExpiCHO-S cells, you can confidently expect similar Glycan profiles to your transient workflows. Both of these samples were harvested on day 14 as well, and it's important to note that the transient sample was also from the standard protocol. So in summary, ExpiCHO stable production medium is a new medium that will facilitate transition from your transient needs into stable protein expression in your CHO cells, as well as it has been shown that no adaptation is necessary when you go from your transient into using the expression medium into your stable producing clone. And then the medium also supports large-scale bioproduction runs. And as mentioned, also the product quality attributes show consistency between transient and stable clones. Again, liquid and AGT formats are also available. I would like to thank the R&D support team as well as the business support. Thank you for listening, and for further questions or comments, feel free to contact me at shreya.lowmaster@thermofisher.com. Thank you.
Thank you, Shreya. So with our first question, go ahead and feel free to type questions into the chat window. I see a couple in there. So the first one that I see says, what is the difference between Freedom CHO and ExpiCHO systems?
Yeah, so the Freedom CHO is a cell line system that comes with a vector, and it's more focused on the cell line, whereas the ExpiCHO system it facilitates research to your manufacturing needs, and this will include the ExpiCHO expression system kit that has the expression medium, which is the transfection medium, as well as the stable production medium, which is for when you scale up, and then also the cell line, the ExpiCHO cells, and also the transfection reagents. And again, this is part of a platform, whereas FreedomCHO kit is not.
Okay. And what vector do you recommend using with the platform?
We would generally recommend a vector that does not require cell line engineering, so an antibiotic-based vector, such as pcDNA 3.3 or 3.4.
And what was the stability criteria for your stable clones, and what percentage of clones that were evaluated met this criteria?
So our stability criteria was at least 30 generations. So this clone in particular was stable for 30 generations, and 20% of our clones met this criteria.
And can you share the outgrowth in your single cell cloning step?
I'm not sure if I understand the outgrowth.
We'll see if that question can clarify. How many wells survive?
Oh, generally speaking, again, it's 20% cloning efficiency is the percentage we looked at that grew and looked to be monoclonal.
Okay. And do you have any specific vector recommendations other than pcDNA 3.3 and 3.4?
Yes, Cytovance has done work with a different vector, so there are multiple vectors that are viable with this system.
And what media, I believe in reference to the question above about how many wells survived in what media?
So at that point, you should be using the ExpiCHO expression medium for that stage.
Okay. And then a follow-up to the stability question, what level of titer specific productivity needed to be maintained to be considered stable?
So generally speaking, the level of titer we expected was no more than a 20% drop. And it needed to be stable for, in our situation, 30 generations were sufficient.
Okay. So what percentage of cells are stable for more than 60 generations?
From this case study, we did not have any stable cells that were greater than 60 generations stability. However, we do understand that you would want it to at least go 60 generations, so it could go from the research scale through manufacturing process, and we were also doing work to further prove that.
Okay. And did you see a lag in growth using the shaking 6-well plates?
There was not an immediate lag that was noticed, no.
Okay. So I think we have time for just one more question. When do you switch between ExpiCHO expression medium to ExpiCHO stable production medium?
So again, ExpiCHO expression medium is a transfection medium, so we recommend to switch into the ExpiCHO stable production medium after selection. And again, ExpiCHO stable production medium is not optimized to support high efficiency transfection.
Okay. Well, thank you, Shreya.
Thank you.
And thank you to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcast. Look for those announcements in your inbox. Thanks again.